Okay, so question number one, make sure that you always read these questions and make sure that you understand what it's asking. That's the big point for a lot of these. So it says the data we collected, or the data that we collected from a statistics class, the column heads give the variable, and each of the rows represent a student in the class. How many variables are there? So, how many variables do we have? 9. Yeah, you just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 headings, 9 variables. So pretty straightforward. Moving on to question number 2. So this guy, still pretty much the same columns that we're working with. I believe it's the same exact information. Nope, it's changed some. Just kidding. But still the same style of what you want to do. So you got some nice multiple choice on this question. So it says the data we collected from a statistics class, the column head gives the variables, and each row represents a student in class. Complete parts A and B. So part A says, is the variable eye color numerical or categorical? And then explain. So, eye color. What do you think? Definitely categorical, right? Because, I mean, we have words. When you have words, you are definitely going to be categorical. Okay? So now when we come down here, we know that it's categorical, so it's got to be either B or C. So we got to figure out, well, which one is it going to be for sure? So it says for B, the variable is categorical because the values are numbers. B or C, the variable is categorical because the values are categories. What do you think? Yeah, definitely C, right? Definitely C. Where did I put the pen? Sorry, I lost my pen for a second, and I put it back. Silly me. All right. So definitely going to be the C guy. I should have gone back on number 1. Sorry. Need to fill this in. So there were definitely 9 categories there. All right. Then the next part, it says, is the variable weight numerical or categorical? Explain. So weight, what do you think? Say it again. Numerical, right? So you said it was B, so let's come down and take a gander at this. It says B, the variable is numerical because the values are numbers. Absolutely. I mean, you only had 2 choices there once you knew if it was numerical or not. And again, remember, numerical is all about measured numbers. That's where the numerical comes from. It's a measurement. Okay, that's kind of the big difference between, categorical and numerical. Besides that, categorical most of the time uses categories, words. All right. So question 3, the accompanying data were collected from a statistics class. The column heads give the variable, and each row represents a student class. Suppose you decide to code handedness using right-handed as a label for the column. How many 1s and how many 0s would you have? All right. So we are coding handedness. This column that's right over here all the way on the right side. The key in this is that it says using right-handed. What does that mean in terms of coding? Who's going to be 1? Anybody that's right-handed is going to be the number 1. So that means anybody that's left-handed is what number? 0. So all you have to do is count that information up, and we've got our answer. So how many right hands do we have? 5. So that means we have how many 1s? 5. Remember, we're coding right-handed, so there are 5 1s because we have 5 people that are right-handed, right? And then in the end, how many zeros were there then? 4, because we have 4 left-handers. Does that make sense? So in the coding, make sure that you read what they're going by. That's the key to this one, that they were coding by right-handed. So that means anybody that was right-handed was a 1. Okay? Any question on number 3? Cool beans. All right, question 4. Question 4 has multiple parts to it. So it says researchers conducted a study on brain size as measured by pixels and magnetic resonance imagery, MRIs, scans. The numbers are in hundreds of thousands of pixels. The data table provides the size of brains and the gender. Complete parts A through C. So the first thing it wants to know, is this data right here stacked or unstacked? It is stacked because it contains 2 categories all in one. Who are the 2 categories we are containing? Male and female. They're all together in one stack. So that is definitely stacked. Definitely stacked because it contains 2 different categories all in one category. All right, so it says explain the coding. What do the 1s and 0s represent? So anybody that's a 1 over here, what does that mean? We're male. Anybody that was a 0 then was female. Yeah, and taking this on the computer, this is actually, these guys right here, they're drop-down menus. That's why you kind of see the bubbles at the bottom of the sheet right there. It's a drop-down menu. So you would click on the little arrow and it would drop down your choices and you pick the one that goes in there. Okay? So that's why you kind of see those 1s, 2s, and 3s that are up there for your blanks. That means those were drop-downs. All right, so part C then says if you answered stacked in part A, then we need to unstack it into 2 columns labeled male and female. If you answered unstacked, then we want to stack the data back up into 1 column with the appropriate name for the stacked variable. Well, obviously we named it stacked, right? So that's going to take out which 2 choices right away? A and C, they're gone because that is stacked information. So we have now narrowed our answers down to B and D. So you kind of have to, it's a little bit easier for you, a little bit harder for me because all my information is back on the other page. You just got to figure out, well, which one represented the correct group. So you can kind of look at your males. How many males do you have? 6, right? Well, there's only 1 up here, B or D, that has 6 males. So it's got to be B. So it's just kind of looking at the numbers and making sure that your information matches. Okay. All right. Any questions on number 4? Perfect. All right. This one is where you're going to want to use that calculator for all 3 questions because you're going to be doing some percentages and changing stuff around. So this is where you definitely want to use that calculator. So question 5, a statistics class made up of 18 men and 17 women. What percentage of the class is male? How are we going to get that percent? Yeah, add the women and female. Add the women and female. Add the women and the men. And what do we get when we add those together? So take these 2 numbers, 35. And that's going to be our denominator because that's how many people we have. What should be in the top? What should be in the numerator? 18, because we're all about the males. So 18 goes up in the top. Then all you need to do is do the division and make sure that you round to the nearest whole number. So make sure that when you guys are going through this, when you're on that computer, that you read that fine print right below some of your blanks sometimes, because it's going to tell you how to do the rounding. So you jump into your calculator, you take 18 divided by 35, multiply it by 100, and round accordingly to what? 51.4. So she typed this up wrong. It says round to the nearest whole number. It should have been round to the nearest tenth, because I believe that's what it says on your guys' paper, right? Round to the nearest tenth?
It said round to one decimal place.
One decimal place, so that's tenth. So what'd you say again, Jeffley? 51.4. On here it says round to the nearest whole number. What would you have round to the nearest whole number? What would that have been? Just 51. Yeah. Yep. Okay. So, part B. A different class has 283 students, and 58% of them are men. How many men are in the class? So how do I get that? There you go. Turn that percentage into a decimal, which what would this be as a decimal? 0.58. And we're going to multiply that times the 283. And what do you get? I actually don't need that equal sign there. Say it again. 164. I like it. Because again, those directions say round to the nearest whole number. I mean, if we rounded to a decimal, that would be weird, you know. I mean, how do you have like points whatever of a man? That's just weird. Either you are a man or you're not. Okay? All right, and last but not least, it says a different class is made up of 54% women and has 27 women in it. What is the total number of students in the class? How do you think this is going to work?
You do the opposite.
What do you mean the opposite?
Instead of multiplying by percent, divide by percent.
Okay. So if we divide by the percent, so who are we taking and doing what to?
We're taking 27 and dividing by 0.54.
Okay. And what do you get when you do that? 50. There you go. That's one way to do this. Also, on some of the other ones, just kind of talking about this, you could have set them up as proportions. You could have set them up as proportions. Show you that real quick. So we're talking about a class versus the percent. We know percents are out of what? 100. And we put our percent above this. This is the part, this is the total. The numerator is the part, the denominator is the total. So we can use that same logic over here. Do we know how many men are in the class? That's X. So we don't know the part. Do we know how many people are in the class? $283. Cross multiply and solve real quick, you get the same answer. Same principle can be used down here on part C. Do we know the part of the percent? 54, right? And how much is a percent out of? 100. Do we know the part of women? It does that. Do we know how many people were in the class? No. Crazy OneNote. And there you go. Do your cross multiplying and solve. You get the same answer. Cool beans? So you can think about it either way. Doesn't hurt my feelings any or anything like that. Doesn't hurt the math god feelings. You know, as long as you can get to that answer. Cool? All right. All right. Number 6. Nice little quick multiple choice. All right. And again, it's going to be select the best answer that's down below. So it says indicate whether the study is an observational study or a controlled experiment. So it says a researcher is interested in the effect of music on memory. She randomly divides a group of students into 3 groups: those who will listen to quiet music, those who will listen to loud music, and those who will not listen to music. After the appropriate music is played or not played, she gives all the students a memory test. Well, first off, based off of that information, do you think it's controlled or observational? Controlled, right? What's the control in this? She's choosing the music. And some people don't get music, right? The people that don't get the music is the control. Okay, because they're not being a part of the stimulus. So we definitely know this is controlled, so obviously it can't be B, and it cannot be D. So now you have a 50-50 shot. It's either A or C. So let's read these. So A says, this is a controlled experiment. She controls for factors prior to assigning students to the control group and 2 random treatments. This is essential to conducting a controlled experiment. C, this is a controlled experiment. She assigns students to to the control and treatment groups at random in order to control for all relevant factors aside from the effect of music on the memory, which is essential to conducting controlled experiments. What do you think? A or C? You think it's what? You think it's A, Miguel? Why?
Because if she was doing a controlled experiment and she wanted all factors to be controlled, it would have been an observation, wouldn't it?
She wanted all factors to be controlled?
Oh, wait, no. She wants them all to be controlled. Never mind. It's C.
Okay. So he says C.
I
He don't know. He's talked himself out of the A.
Yeah.
The answer is going to be C. And here's some of the big things. Because it's random. That's huge. Okay? Also, it says if you look at part A, it says she controls for other factors prior to assigning. What is there to control prior to that? That doesn't make any sense. Because all the factors are controlled during the experiment, not prior to it. But the big thing is that in here, it's because she's assigning random order. That's essential for a controlled experiment. Does that make sense? So just a couple of things. Like I said, sometimes you got to really make sure that you read through these things. At least you had a 50-50 shot once you knew that it was narrowed down. Okay? So the answer is definitely C. All right, Q7. I definitely used a calculator on this one, but I did it for part E. So the very, very last question on this one. Part E is when I actually used that calculator. Okay, so it's a small part in this one. So it says the histogram shows the distribution of the numbers of televisions and homes of 95 community college students. So here's our histogram, which is huge. Okay? So let's start answering some questions, because this is all about answering observations about what you see here. So it says, according to the histogram, how many homes do not have a television? She has some weird numbers down here. 48, 4. So her numbers are a little crazy. Let's make sure. Looks like she put the histogram for number 8 in this one. So that's all right. No worries. You have the histogram in front of you. You have it on your sheet of paper. So when we look at the histogram that's actually on there, what did you get for this guy? 4. Perfect. There are 4 homes that do not have a television. Okay? Now, this one, if you're not careful, you will give me the wrong answer on this one. So be careful when you read this. It says, how many televisions are in the homes that have the most televisions? So, I don't have the histogram on here. So, how much is it? How many televisions? How many televisions, though? 8. When I first read this one, I thought it was talking about the mode. Because when I read this, it says, how many televisions are... Gosh, quit moving. How many televisions are in homes that have the most televisions? So when I read that, I'm thinking, most televisions, who has the most? So this is actually talking about the number of televisions. Who has the most? And that would be 8. Does that make sense? So just be careful when you read some of these. Okay, because they definitely, that wording needs to be looked at very, very carefully. Okay? So this is one that threw me off when I first read it and went through it. But it's actually talking about the most number of televisions, not the mode. Okay? All right, so now it says, how many homes have 3 televisions? So you look at the bar for 3 and tell me what you got. Say it louder. 28. Perfect. Look at that bar for 3 and you tell me what you got. It should be 28. All right. Now it says, how many homes have 6 or more televisions? 6 or more televisions. 6. Because you got to look at your columns. You got to look at 6 televisions. They have 5. Look at 7. They don't have any. Look at 8. They have 1. So 5 plus 1 is 6. Now this is the one that I actually had to use the calculator on real quick. And so it says, what proportion of homes have 6 or more televisions? So, well, we know how many have 6 or more. How much is that? 6. Out of what's the total? 95. And you need to make sure that you reduce this down. If this can reduce, you need to reduce it down. So you go to that calculator. Remember, your best friend is alpha y equals. And you put in that 6 over 95. You hit enter and see what happens. And does that reduce down? No. So the answer is 6 over 95. Because if you look at the directions right here, right underneath it, that special fine print, it says type an integer or a simplified fraction. Remember, integers are numbers that have no decimals. So definitely couldn't take 6 divided by 95. That's a decimal answer. So it really wanted you to put the answer in as a fraction. Okay? That's why I leave it as 6 over 95. Cool beans? Like I said, small little calculator work on this last one, and really was just to make sure that does it reduce. That's the calculator work I'm talking to you about. Okay. All right, number 8. And do we have the right frequency table for this guy? Yeah, we do. Okay. Perfect. So number 8, it says, the histogram shows frequencies for ages 25 ages of 25 randomly selected CEOs. Approximately what is a typical age of a CEO in this sample? All right. So simple question. So you're looking at this. What is typical? 56 to 60. In other words, when they talk about that typical, they're looking for that highest bar, almost that mode. So 56 to 60. So we go down here, and the answer has to be B. Okay? And I meant to tell you a second ago, questions 1 through 6, they were all from 3.1. Those were all from 3.1. Questions 1 through, chapter 1. Those were all chapter 1 questions. Starting with 7 that we just did a second ago, this is where we're starting that chapter 2 information. Okay? So if you're kind of thinking about how is this broken down, 1 through 6 is chapter 1. Starting on question number 7, we're starting chapter 2. All right, question number 9. Lots of information on this one. Lots of information. And I did use a calculator in this one on part D. Question number 9, I did use a calculator on part D on this one. So did she give us the right histogram table again? Number of siblings. Number of siblings, perfect. And you'll also notice that some of the blanks that you have down here are numbered. That's because it's multiple choice, or it's a drop down. Okay? All right. So the accompanying histogram shows the distribution of the numbers of siblings, brothers and sisters, for 2,000 adults surveyed in 2012. Use the histogram to complete parts A through D. Okay. So part A says, tell me about the shape. So if you look at this guy, what's the shape? Yeah, right skewed. Right skewed. Remember, the skew is all about where the tail is. So if we kind of drew our picture on this, our tail is over on the right side. Okay? So definitely right skewed, B. Perfect. So question B says, what is the typical number of siblings approximately? So if you look at this, what do you think? Say it again. 2 to 3. I don't like that they say 3. I would have actually said 1 to 2 because those are my 2 highest bars, but that's not one of the choices in the drop down. So that's why it's important to make sure that you read all those choices. Because if you look down here, 0 to 1 is one of your choices. Well, that doesn't make any sense. They're not the highest. 2 to 3, this one contains the highest, although 3 is not the second highest, but it's the closest. Because anybody after that starts going lower and lower and lower and lower and lower. So has to be 2 to 3. Make sense? Although I would have said 1 to 2. Makes a little bit more sense. But that's just me. All right, so C says, how many people in this survey have no siblings? So you come up to your graph and you look at no siblings and you give me a rough estimate. Say it again. 80 to 100. Although I wouldn't have probably said 80, I would have probably said 90 to 100. I mean, it's really darn close to 100. It's not at 100, but it's darn close to it. So going with their choices has to be A. 80 to 100. Although I think 80 is a little low for what they're giving us. They're lowballing us. Now, the reason why I use a calculator on part D because we're figuring out percents. Okay, notice there are 2 blanks here because it wants you to use the information from part C to figure out those blanks. So in order to get your first percent, and also notice it says round to the nearest whole number. So that's why we have to use that calculator because we got to do some dividing. So if 80 people do not have siblings, taking that from part C, how do I figure out that percent? Take the 80 divided by the 2,000. That will give us our first answer. What is 80 divided by 2,000? 0.04 multiplied by 100, and what do we get, T? 4%. Perfect. Take the 80 divided by the 2,000, multiply by 100, you got your percentage. Okay, to get the second percent, well, step it. Take the next number. What if 100 people had no siblings? So you just repeat the process. 100 divided by 2,000. What is 100 divided by 2,000? 0.05 and multiply by 100, you get 5%. Cool beans? Perfect. All right. Jumping on to number 10. So it says the table linked below shows the average lifespan for some mammals in years. Graph these average lifespans and describe the distribution. What is a typical lifespan? Identify any outliers and report their lifespans. If you were to include humans in this graph, where would the data point be? Humans average about 75 years. All right, so lots of questions there. So the table is actually on the back side of your piece of, or in your packet. So that's where you see that same table. And again, one of these is also a drop-down menu. So how I kind of approach this when graphing, and just so you know, you'll also have StatCrunch available for you. StatCrunch will be available for you during this. You'll have the little gear up here in the corner that says question help. You click on that and it will have the StatCrunch option available for you that you could click on and open up. Okay? Woo! Too far. So we have 3 graphs. Okay? 3 graphs. So how I approach this is I went and I looked at the outlier or the largest, okay, my largest sums. And I figured out how many of those there were. So up here, oh, I see the Asian elephant was 40. So that's a pretty long lifespan. The hippo was 41. So far we got 2 up there. And I don't see anybody that beats those 40 and 41s. So that means our furthest column to the right has to go up to the number 2. So when we come down here and look at our graphs, so we know B is out. Because if you look at B, it only goes up to 1. That makes sense? So no, it ain't B. So it's got to be either A or C. So let's take a look between A and C. So remember, each one of these little columns represents from like 0 to 5, 5 to 10, and so on and so forth. Okay? I believe it lines up like that. Look at yours. Yeah. So 0 to 5, 5 to 10. All right, so if we come back up in here and I look at maybe the smaller routes. So I've got 5, 8, 7, 8. So that's about 4, right? The hardest part on this one, and this is the tricky part, is to know what your columns are kind of going by. Because, well, I mean, it seems like it's going by 5s, but it's a little deceiving on that part because they're not exactly going by 5s, which is horrible that they didn't kind of label this a little bit better. So based off of what we found like 4, right? So you think C is not bad. But I would double check one more thing. Look at the 10 values. So if you look at the 10 values, we have 10, a 12, Whoa. Another 10, another 10, another 12. So that's about 5, right? So when we come down here and we look at that information, so we knew we had about 4 numbers that were around the 5s. And we have how many numbers for the 10s? 5. So we look at this. Using the 20s is really good. So still with that information, I mean, these are still kind of roughly coming about. I mean, this guy's a little bit larger than 5. This guy's a little bit lower than 4. You know, again, maybe we should do what Miguel said. You know, it's a little tough to tell there. So let's look at 20s. So we got at least 1, 2, 3. So 3 of those. So this guy goes up to 3. That's not bad. What did this guy go up to? 1. Right there's the big difference. So overall, I would almost go with graph C, but you want to make sure that you check some of those other points to make sure that this guy was close in the beginning, but it's not the one that we wanted. So the answer to this guy was A. And again, that's something I had to go back and look at because like I said, they're not truly counting by 5s in here. They're not. And that's the part that'll drive you nuts. Because like I said, we found 4 numbers that were between 5 and 10, right? But this guy ain't going up by 5s. Does that make sense? So that's why I said this is one that you got to make sure that you take a look at because they should have put what each column width was, but they didn't, jerks. All right. So now you have that information. So we know what it looks like now. That's going to help us with the other questions. Yeah. So it says, describe the shape of the histogram. What do you think? Right skewed. Yeah, definitely. So definitely that right skewed answer. So, and who was right skewed? That was, it was a drop down. Never mind. It was a drop down. All right. From here, what now? Typical lifespan, who's that going to be? Say it again. 10 to 15. So let's take a look up here. Where are most of my values? Yeah, that 10 to 15 answer, right? Because definitely can't be, oh gosh, this thing. Less than 10, because if you're less than 10, you're taking out the giant bar that we had, right? So definitely B. Like it. All right, next one says, identify any outliers. Who do you think are our outliers? B, right? The elephant and the hippo, because there's a giant gap between those. And those are the first 2 guys that we talked about. And then down at the bottom, if you were to include humans in this graph, where would that data point be? Now remember, back at the top, it said humans average 75 years. Yeah, it'd be the B. It'd be way off to the right. It'd be way off to the right. Another outlier. That makes sense? Cool. All right. Jumping to the next guy. So it says, according to the organization, there are 5 leading causes of preventable death in a region. They are shown in the graphs to the right, well, actually for us, down below, where HBP is high blood pressure, TU is tobacco use, HBG is high blood pressure glucose, PA is physical activity, and OO is overweight and obesity. Use this graph to help us complete parts A through C. So it says, estimate how many preventable deaths from high blood pressure. Okay, it says round to 1 decimal place. Where do you think that bar goes to? Now this bar, looks a little bit lower on this graph than what it really is. What does it look like on your graphs? 7.5. Yeah. 7.5 is the answer. It's really halfway. This one looks just a little bit lower than that. That's a good question. I don't know. I would assume it might mark it wrong. But, yeah, if it looks like 7.5, let's be safe on that one. Let's put the 7.5. I don't think they're going to try and give you anything that's weird and be like, no, it should have been 7.43. I don't know why you didn't know that, you know. Okay, so the next one says, estimate the amount of deaths from tobacco use. Looks like 6, right? So, and again, it says round to the 1 decimal place, so you'd actually put 6.0. 6.0. Okay? So, the last question, well, not the last question, but C, again, this is a drop-down menu, so it's almost kind of like multiple choice. Does this graph support the theory that the greatest rate of preventable deaths comes from overweight and obesity? So does this graph basically say that it is typical that people die because we're overweight and obese? No, right? So you circle the no, or you'll click on the no in the drop-down menu. And then it says the graph blank supports, does or does not. So does not, right? Because you're saying it does not support. Does not support the theory that the greatest rate of preventable deaths comes from overweight and obesity, because overweight and obesity do not cause the greatest number of preventable deaths. Do not cause. And the reason why you put do not cause is because it's saying it is the greatest. It's not saying that it doesn't cause deaths. It's just not the greatest. Make sense? Okay. D. It wants to know what kind of bar graph this really is, because it is a bar graph. Which one was it? The P one, the Perot. Yeah. And remember that the Perot chart, we know this is a Perot chart because it organizes it from the greatest to the least. Perot charts do that. They take the greatest column, put it first, and then they stack it all the way to the smallest column. Cool beans? Yes. Good. I'm glad you agree. All right. Halfway there. So it says the table gives information on majors at a certain college. Sketch an appropriate graph of the distribution and comment on its important features. So again, kind of like what we just did with the lifespans, but we're doing it bar graph style. Okay? Again, I just start looking at these different sections and I start saying, okay, which bars match up with it? So like humanity should be at 37. So if I look at my bar graphs, 2 of them I can take out right away. A and B. They're gone. Because those graphs don't even stretch to 37. So right now, C and D are still in play. So then from there, well, it looks like there's a big difference in the math and science. So let's see which one is the correct one. So it says math and science should be at 29. So if I look at these, which one of these graphs is at 29 for math and science? D. So graph has to be D. It's the only thing that makes sense with what they gave us. Okay? All right. So which of the following would be appropriate graphs for showing the given distribution? So This question is asking for what other graphs could we use? And select all that apply. So when you see that select all, that means there's more than one answer. Okay? So who's going to work? Who else should we use? Yeah, pie chart, absolutely. The dot plot is not going to work on this one because the dot plot is more for numerical category. What kind of, or not numerical category, numerical variables. What kind of variables do we have here? Categorical. Who else works for categorical? That's the big key on this one. Not a histogram. That's numerical. Say it again. Yeah, the Perot chart. Because the original graph was not a Perot chart. Original graph was just a bar graph. So putting this in order from the tallest bars on down also is valid. So remember, this question is asking about what's going to work in addition to what you just saw. That's for numerical. And you can't connect those. There's no way. How does history connect, or humanities connect to social science, which connects to math and science? And bar graph, Perot chart, pie chart are categorical representations. Everybody else that they have up there is numerical. Which of the following is the best description for the distribution? The mode is math and science, the mode is social science, the mode is interdisciplinary, the mode is humanities. Humanities, because that was the largest bar, right? There you go. That's what was typical. Cool beans. All right. The accompanying graph shows the distribution of data on whether houses in a large neighborhood have a garage. A1 indicates the house, A1 indicates the house has a garage, and A0 indicates no garage. Is this a bar graph or a histogram? How could the graph be improved? Be careful on this question. So when you guys look at yours, you can see that your bars are connected. So this should actually, there shouldn't be a gap right there. They should be connected together. But that's neither here nor there right now. So the question is this a bar graph or a histogram? What do you think on this guy? Histogram? Okay, and I'm going to go with you on the histogram. It is a histogram. That's going to come in what we're going to talk about right here. So we know it's a histogram. We have two choices now. Okay? The histogram, because the values on the horizontal axis are numbers. Okay. Histogram, because the bars touch. It's because they touch. That's the key. If your bars touch and you got numbers down below, you're looking at a histogram. This is one of those questions where I could have almost argued some other stuff too. I could almost argue that it's a bar graph because it's kind of been coded that way. Okay, they use coding on this, which generally coding is used in categorical variables. I could almost argue other answers on this one, but the fact remains is that my bars touch. That's a histogram. That's the key. And again, like I could almost argue the last one. The graph is a bar graph because it doesn't matter which order the bars are placed in. That's true. Doesn't matter. I could, if it was a bar graph, because I could put it in the Perot chart. Okay, but it doesn't have to be a Perot chart. But again, the key is the bars touch. If it's a bar graph, the bars don't touch because generally it's categorical. Okay? All right, so how could the graph be improved? So we got some choices here. The graph could be improved by changing the units on the vertical axis to relative frequency. This would show the proportion of houses in the neighborhood with or without garages instead of the frequency of houses. Okay. The graph could be improved by containing more categories under garage to show more variability and detail. For example, 1 garage, 2 garage, and so on and so forth. C, the graph could be improved by switching the position of the garage categories. This would sort the graph from most frequent to least frequent, changing it to a Perot chart. And D, the graph could be improved by making it a bar graph or a pie chart. This would make the variable garage be seen as categories, not as numbers. What do you think? Which one up here would help improve the graph? D? Absolutely. Because like we said from the beginning, this is why I could argue some of those bar graphs, you know, because this really is a categorical variable. So changing it to the frequency, or changing it to the relative frequency, I mean, it's really categorical. So that, I mean, that doesn't really improve this any. And especially when you look at the relative frequency, it turns them into decimals. How many people really want to read and understand decimals that well? It's not really much of an improvement. Okay. Contain more categories. I don't think we need more categories, because if you add more categories, it might get a little bit more confusing. Okay. And especially if we're using coding, codings are 1s and 0s. It's a little bit harder to take 1s and 0s to do that too. Switching this around, well, but it's not a bar graph to begin with. So doing this doesn't make any sense at all anyway, because it's not a bar graph, it's a histogram. D is the only logical choice for this, because we know it's categorical, so why don't we make it look categorical? Why don't we turn it into a pie chart or a bar graph? Make sense? Yeah, so this is one of those questions that I put on there. Be careful on this one. Read it carefully. Think about it. Because there could be arguments for a lot of these answers, but they're really looking for the best one. Make sense? All right. So, horrible picture. Your picture is not really kind of any better than this one. So it says the accompanying pie chart reports the number of hours of sleep last night for 116 college students. What would be a better type of graph for displaying this data? Explain this pie chart, or explain why this pie chart is hard to interpret. So there's our pie chart. So what would be a better type of graph for displaying these data? Select all that apply. What do you think? So a histogram, a bar chart, a dot plot. You chose B, the Perot chart. Okay. Well, first ask yourself this question. Is it categorical or is it numerical? It's numerical. You're measuring this. These are the amount of hours I slept. So right away, because you know it's numerical, 2 of these go away. B and C. So the only other logical ones would be A and D, because those deal with numerical variables. Does that make sense?
Pie charts are categorical?
Uh-huh. Pie charts are categorical.
So why wouldn't we select? Oh, because there are numbers here.
Yeah. That's a measured value. Like when I asked you, Miguel, how long do you sleep for? Usually at night.
6 hours.
See, that's measured. That's a measurement. That's like saying, how much do you weigh? Don't tell me. But, you know, that's a measurement. How old are you? That's a measurement. Okay? they did us a disservice by putting it in as a pie chart, which leads us to the question, why is this pie chart hard to interpret? So it says, obviously you can't see the colors, but if you're looking at it on the computer, you'd be able to. The colors chosen for the chart are too similar, making it hard to tell which slice goes to what category. Ours is black and white, so that's definitely a harder task for us. There are so many possible numerical values causing the pie chart to have too many slices, which makes it difficult to tell which is which. The pie chart shows only the proportions of students who got a certain number of hours of sleep, not the frequency of students who got a certain number of hours of sleep. The sample of students is too large, causing too many different results for the number of hours of sleep. Now remember, the question says, why is the pie chart hard to read? What do you think? Say it louder, Jennifer. B, definitely. There's too many slices. Too many slices. If you're on the computer, you can see the colors. The colors are not that bad. It's not as bad. The problem is that there are too many slices to this bad boy. Okay? And some of them are just like millimeters thick. Yeah, very small. Very small slices. Does that make sense? I mean, obviously, you don't want to talk about this. The pie chart shows the proportion of students, and not the frequency. Well, a pie chart will never show frequency. Okay, so that's why we can throw this guy out. Pie chart's not all about that. Down here, the students is too large, causing too many different results. Well, that might not always be the case. Again, this is about why the pie chart is hard to read. That's just junk. That's talking about your sample size, not the pie chart. So really, in actuality, you could argue A and B, but B is the better choice. There's just too many. Too many slices. Okay, so this question, a lot of drop downs on this one. There are a lot of drop downs on this one. There are a total of 13 drop downs. That's why you see those numbers after it. That's a drop down for you. All the choices are on the back of the page up near the top. So, refer to the accompanying graph, which shows the time spent on a typical day, talking on the cell phone for some men and women. Each person was asked to choose the one of 4 intervals that best fit the amount of time they spent on the phone. For example, 0 to 4, 12 or more hours, complete parts A through D. So here's what we know. Okay? All right. So it says identify the 2 variables, then state whether they are categorical, numerical, and explain. So for your first drop down, it says one of our variables is gender, number of users, number of cell phones. It's gender. Okay? Because the number of users, that's not what this chart is about. I mean, we have number of people, but that's not one of our variables. That's like the frequency. Okay? So frequency is never a variable for us. And the number of cell phones, again, that just kind of goes along with the number of people. But down here, this is all about the hours on the cell phone. So you got to throw that guy out. Number of cell phones, again, that's kind of like your frequency. So your first guy is really about the gender, which is a blank variable, numerical or categorical? Definitely categorical. And then, since it describes blank, qualities or quantities? Qualities. All right. So the next one says, the other variable is blank. Type of cell phone, time range, age of user. Time range, right? Because the type of cell phone is nowhere to be found up there. We don't care what kind of phone they're on. The age of the user, that information ain't up there anywhere. So definitely time range. which is there should have been a blank there, but she put the parentheses, numerical or categorical variable? What do you think? Numerical. It is absolutely categorical. Do you know why? Because even this question threw me off. You have a set range. You are falling into different categories. Are you 0 to 4? Are you 5 to 6 or whatever? Does that make sense? These are categoricals. Even though, yes, you're kind of measuring yourself, but after you measure yourself, you put yourself into a category.
So once you divide numbers up into groups, sets of numbers, then it turns into categories.
Also, when you look at this, all my bars do not touch. If that was really numerical, your bars should probably touch. Does that make sense? But you are putting yourself into different categories. Are you 0 to 4 category? Are you 4 to 8 category? Are you 8 to 12 category? Just like the number of garages. Number of garages, like we saw a moment ago, that could definitely be numerical. But we kind of categorized you as either you have a garage or you don't. Make sense? All right. So, yeah, that second question is one that you watch out for that guy. Okay, because this is definitely categorical because we had groups that you put yourself into. So is the graph a bar chart or a histogram? Well, right away, you know that the bars, are they touching? No, so we know it's got to be a what? Bar chart, bar graph. So there's only two answers. Well, there's three possible answers for this. So A, the graph is a bar chart. It's the better choice since both variables are numerical. Well, we can throw that out because both variables are what? Categorical. So B, it says the graph is a bar chart. It is the better choice since one variable is categorical and the other is numerical. Throw that guy out. That don't make any sense. Or E, the graph is a bar chart because it is a better choice because both variables are categorical. Yeah. Only makes sense with part E because both variables are categorical from what we said. I have an answer. Oh, we didn't answer the last one. Gosh. Yeah. So is this quality or quantity? It's quality. It's a quality. It's a characteristic. It's where you fall as a characteristic of you. How many garages, or whether you had a garage or not, is a characteristic of your house. It's a quality. Sorry, thank you for that, T. If you had the actual number of hours for each person, rather than just an interval, what type of graph would you use to display the actual numbers of hours? Dot plot, histogram, bar chart. Say it again. You could argue dot plot, but what else would be a little bit better than that? Histogram. Histogram is just a little bit better than the dot plot, just so you know. Histogram is a little bit better. Because again, remember, if you have a ton of data, you got to put a dot for each one of those datas. But if you're in the histogram, it's just making a bar for the frequency of it. Cool beans? So the histogram should be used, not sued, used, since the time would be a blank category now. That's when you're numerical. Because you're not placing yourself into a category anymore. You are telling me, oh, I'm Miguel and I slept 6 hours. Okay? So we're not placing you into a certain range. So it said, compare the modes of the two distributions and interpret what you discover. What does this say about the difference between men and women's cell phone use? So the mode for the women is what? 4 to 8. Because why? It's the highest bar, right? It is the tallest bar. The mode for men is 0 to 4. Because it's the tallest bar. Therefore, the distribution shows that blank talk more. Women. You women in your talking. Now, any questions on D? Okay. All right, so number 16 says the histogram shows the age of 25 CEOs listed on a certain website. Based on the distribution, what is the approximate mean age of the CEOs in this data set? Write a sentence in context using words in the questions, interpreting the estimated mean. All right, so from 6 to 15, that was all chapter 2. Now that you start seeing this word mean, we're jumping into chapter 3 because we didn't use the word mean until chapter 3. So from 16 on down now through 25, this is all chapter 3 questions. Okay? So 1 to 6, or excuse me, it was 1 to 6, that was chapter 1. 7 to 15 was chapter 2. 16 to 25 is chapter 3. All right, so looking at our histogram, what do you think the mean age is? $56 to $60 again. Because again, remember when we talked in class, this is pretty symmetrical. And remember that in symmetric, the mean, median, and mode are all right in the middle. So the answer for this should be between 56 and 60. You don't need to actually do the calculator to figure that out. Although it'd be a little hard to figure out the mean because you don't know what numbers were in what. When it's symmetrical, your mean, median, and mode should be in the middle. Because everybody that's down here balances out everybody that's up there, and it focuses in directly into that middle piece. All right, 17. 17, I used StatCrunch on. 17, I did use StatCrunch on. Okay? Because it's going to ask you to find the mean. It will also ask you to find the standard deviation. Okay? So I definitely use StatCrunch on, which I should probably, well, we got calculators so we can use those. Okay? But we can talk about what I did in StatCrunch. So it says at their installation as Chief Justice of a certain country, the first 6 Chief Justices were 42, 55, 51, 44, 59, and 58 years old. Complete parts A and B below. Part A says find and interpret the mean age at installation. Okay, then it also says the mean age at installation of 6 most recent justices was 63. Did the first 6 tend to be older or younger at the installation than most recent 6 Chief Justices were? It's like a tongue twister. All right, so first things first, let's focus in on the mean. How do you find mean? Yeah, good. Add them all up and then divide by however many there were. So we'd add all these numbers up and then divide by 6. Add all those numbers up and then divide by 6. So in StatCrunch, I would just go into one of my little columns and I would just put in my 6 numbers. And then remember, we'd go up to, I believe it's stat, and you'd run summary statistics for a column. and have it compute all that information out. If you're using your calculator, which by all means you can use your calculator, you press stat, you go into edit, you put in your 6 numbers, and then you go into stat again, scroll over to calculate, and you want to do one variable statistics. And that will give you all the information you need. And you'll definitely want to do that for when we get to the standard deviation. You could do the mean without running that information. So, all right, what is the mean? What do you got? 51.5. 51.5. And speaking of which, I can actually show you the calculator. I don't know why I didn't think about this a moment ago. Go away, go away. Let's bring up the calculator. Silly me for not doing that earlier. Oh, give it a second, it's thinking.
Is that software free?
No. No, this software is not free. All right, so view, hide key press. All right, so you go into stat and you want to hit edit. So you hit enter, and then I'm going to need you guys to give me those numbers. 42,
55,
55,
51,
51, 44, 59, 58. Okay. So you hit stat again, you go over to calculate, and you want one variable statistics right at the top. And then you just hit your enter a couple times, and right at the top, the X bar, 51.5. There's your information. All right. So let's go back to our OneNote. So it says the mean age at installation of the 6 most recent justices was 63. Did the first 6 chief justices, that's the 51.5, tend to be older or younger than the most recent, which was the 63. So which one is it? Were they older or younger? Younger, right? Because the mean is what? Is lower than the other guys. So that answers the second part right there. Because the mean of the first 6 was less than the mean of the most recent. Make sense? Okay. So next it says find the standard deviation. Okay. Well, again, I told you in class I didn't want you to do this by hand. Although there's not a lot of numbers, you could do it by hand, but that's just silly. Why take up that time? So right here in our one variable statistics, we have all the information we need to get that standard deviation. Where is it? Who's the standard deviation on this screen? It's SX. And according to the little directions, it says round to the nearest 10th. So what do we get? 7.2. So there's your standard deviation. All right, so now it says the standard deviation of the 6 most recent Chief Justices was 9.8 years. Did the first 6 tend to have more or less variation than the most recent? It had less. They had less variation. Why? Yeah. The first 6 had a lower standard deviation than the other guys. The lower your standard deviation, the tighter that data is. The less variations are allowed. The larger the standard deviation, the more variation there is. Okay. Number 18, I definitely, again, use StatCrunch, especially on this guy, because you have 30 numbers for each one of these. And they want the mean and the standard deviation for both of these. This is StatCrunch at its best okay? Or using your calculator. You can do the calculator too. All right? So let's jump into that calculator and let's put in these numbers and get that information. So just so you know, we're talking about college students and surfers Rex Robinson and Sandy Hudson collected data on the self-reported number of days surfed in a month for 30 longboard surfers and 30 shortboard surfers. So complete parts A and B. Like I said, in part A, it's looking for the means. And in part B, we're looking for those standard deviations, and we're going to compare them. Okay. So let's go back into stat. We're going to edit. Remember to clear out this list. Just scroll up to the top and hit clear. Hit enter. And now we can start slapping our numbers in. So I'm going to need you to read these numbers off to me.
It's going to be
13,
21,
21,
14,
14.
7, 11, 5,
Slow down. 6.
6.
Okay.
Another 6.
Another 6.
Yes.
Oops, hold on.
You had a 3 there.
Hold on. Yeah. Didn't scroll back up for me. 6. Then what?
And then 11, 12, 7,
Okay.
13, 8, 9, 21, 4, 5, 4, 22, 10, 16, 5, 10, 16, 6,
Hold on. 6.
7,
7.
9,
9.
15, 18, 13.
That should have been it. All right. So there's our first list. So these are our longboarders, correct? All right. I'm going to go over to list 2, and I'm going to put the shortboards in here. All right. Give me that list.
It's going to be 19, 11, 19, 9, 8, 17, 5, 9, 5, 14, 15, 14, 12, 8, 15, 8,
Oh, hold on. 8. Okay.
that's 88,
Well, no, 88. 8.
16, 9,
9.
15, 11, 13, 4, 17, 13, 9, 19, 13, 16, 13, 19.
All right. And again, in StatCrunch, I put the long borders in the first column, the short borders in the second column, and then in StatCrunch, you can run those quick statistics for it. All right, so here, so we want to run some statistics. First, let's get the long borders. So I hit stat again, I go to calculate, one variable statistics, and remember long borders is in L1. If we wanted to do the short borders, we would change that list to L2. And remember, I told you in class that we can do that by hitting second and 2 to change it to L2. But we're in L1, so I need to go back and change that. Second 1 is back to L1. So hit your enters, and now you have 2 of your answers that you need. You have the mean, and you have the standard deviation. I would make sure that if you can't fill in the standard deviation yet, go ahead and write that number down, so that way you don't have to go back and run the statistics again. So first things first, what is our mean? 10.8. Perfect. What is our standard deviation? And the directions will want you to round to the nearest tenth. 5.3. All right, so we'll put those into the correct blanks. So 10.8 and 5.3. So I come back over here. Long borders, 10.8 is their standard deviation. And the long border standard, 10.8 was the mean, and 5.3 was the standard deviation. Okay. So now we're going to go in and we're going to do the short borders real quick. This is the longest problem because of all the data that you have to deal with. So stat, calculate, one variable statistics, change L1 to L2. So second 2, and now scroll down to your calculate and hit enter. What is the mean for short borders? 12.5. What is the standard deviation? Again, rounded to the nearest tenth. 4.4. 12.5 and 4.4. So we'll come back and we'll fill that in. 12.5 and 4.4. Okay? So right here it says fill in the correct answers below. So blank tend to go surfing more based off of the means. Short borders tend to go surfing more. Make sense? Because they have the higher mean. And then down below. So blank tend to have more varied days of surfing. The long borders, because they had the higher standard deviation. So their varying of days is larger. Cool, cool? All right. 19. All right. So getting into that empirical rule information. So in 2011, the mean rate of violent crime per 100,000 people for 24 particular states was 435. The standard deviation was 176. Assume the distribution of violent crimes rates is unmodal and symmetric. Complete A and D. All right. So just a couple of things to notice on this. They're kind of giving you a nice little hint down here. They keep saying 176, 176, 176, 176, because that's your standard deviation. And that's how they're getting from 435 to 611, is because they took 435 plus the 176 to get 611. Okay? But for the first question, though, it says the graph is a sketch of the distribution of crime rates. What percentage of data should occur within 2 standard deviations of the mean? So they're asking you to figure out that percentage. So remember, this was 68, and how much was that guy? That's 95%. 95%. Okay? So now they want us to start talking about information. So the number 611, we kind of just, how did I get the 95? Because remember in class I said that this is the empirical rule that is 68, 95, 99.7. 68% is 1 standard deviation. 95% goes for 2 standard deviations. 99.7 is 3 standard deviations. It's what we call the empirical rule. And it works like that all the time. 100%. As long as it's symmetric. And 1 modal. All right, so how was the number 611 shown on the graph obtained? Well, I just kind of talked about that to you guys. How do we get from the 435 to the 611? We added the standard deviation, right? So which one of these says that we added the standard deviation? B. B. We added one standard deviation to the mean. We added one standard deviation to the mean. Now this guy right here, it doesn't have like a part to it, so I just called this the third question. I did use a little bit of calculator on this because we're just doing some simple adding and subtracting. They want you to figure out the A, B, and C that are below on your chart here. So they want these guys. Well, how do I get to B? Subtract 176 from 435, right? So what do you get? 259. Cool beans. So we can fill that guy in real quick. So 259. All right. How do I get to A? Subtract another 176. Like I said, they kind of gave you a nice little hint there with the standard deviations written. So how much is A? 83. Oops. And then certainly last but not least, C. 787. Because you add 176 to the 611. So 787. Okay. So it says now we start getting into A, B, C, D, E, F, or all those different parts of the question. So it says between what two values would you expect 95% of the data?
259 and 611.
Nope. 83 and 787. Because that's 95%. Okay, does that make sense? Cool beans. All right. Between what two values would you expect 68% of the data? There you go. 259 and 611. Okay? All right, part C says, if one of these states had a violent crime rate of 440 crimes per 100,000 people, would this be considered unusual? Well, which one did it fall between? It fell between one standard deviation, right? That's why we made these little points. 444 falls between this guy right here. So if you are between one standard deviation, that's not unusual. Usually when we start talking about unusual, you're beyond the two standard deviations. Yeah. So this guy would be a no. And 444 would not be considered unusual because it falls within one standard deviation. Well, that's what we just said. So it's definitely got to be A. Because if you look at the other one, it says no, 444 would not be considered unusual because it's more than two standard deviations away. We just said that it wasn't. And then obviously C and D don't make any sense because
Let's say like on the borderline of the two standard deviation, does it fall into being?
if you're on the line, that means you are one standard deviation away. If you're on that line, you're one standard deviation, or if you're on the other guy, you're exactly that distance away. Yeah. So if one of these states had a violent crime rate of 61 crimes per 100,000 people, would that be considered unusual? Why? It's it's below two standard deviations, right? So we just need up here to find the yes that says it is more than two standard deviations. So it's B. Perfect. Cool beans? All right. Almost done. Almost done. In 2007, the mean rate of violent crime per 100,000 people for 10 regions in the Northeast was a certain country was 343. The standard deviation was 125. Assume the distribution of violent crime rates is unimodal and symmetric. Complete parts A through D. Again, we're doing the same thing we just did a second ago. Although they took the picture away from us. So let's make our own picture then. We can do that. Woo! And we're symmetric. Who's in the middle? 343, because that's the mean. That X bar goes here in the middle. Okay? How do I get to one standard deviation above? There you go. So what's 343 plus 125? Okay? How do I get to 2 standard deviations above? Add another 125, and what do we get? Okay. Then go in the reverse direction. How do I get to 1 standard deviation below? So 343 minus 125. Okay. And so again on this one, I am using the calculator a little bit on this for part A and part B, because we got to do some adding and subtracting. All right. And then minus 2 standard deviations. What do we got? 93. So now we can go up and we can answer our questions. And now you have a picture of what's going on. And remember, again, according to the empirical rule, this right here is 68%. And between 2 standard deviations is 95%. Okay? That's our empirical rule. All right, so we go back up. So you have your picture right in front of you now. Approximately 95% of the observations fall within what interval? And you said 593? Yep. Perfect. Using the empirical rule, between what 2 values would you expect to find about 68% of the rates? Perfect. And then we ask the usual and unusual questions. So if a northeastern region had a violent crime rate of 285 crimes per 100,000 people, would it be considered unusual? Why? Okay, so the answer is what? B. Like I said, it's pretty much the same thing that we just did. They took away the picture, jerks. So if a northeastern region had a violent crime rate of 45 crimes per 100,000 people, would this be considered unusual? Why? More than 2 standard deviations. So the answer is B. Perfect. Moving on. All right. So we got a nice little dot plot below. The dot plot shows the height of college women. The mean is 64 inches, which is 5 feet 4 inches. And the standard deviation is 3 inches. Complete parts A and B below. What is the z-score for a height of 67 inches? So what you see right here down below at the bottom, those are the z-scores. Remember, z-score tells you your standard deviation away from the mean. So if we look at 67, what do you think the z-score for that would be? 1. It is 1 standard deviation away from the mean. What is the height of a woman with a z-score of 2? Here's 2. What's her height going to be? 70. So this is just kind of reading that chart and tell me what you know. But remember, we do have a formula for z-score that you could have used. Remember, the z-score is equal to your data entry minus the mean divided by your standard deviation. So for part A, you actually worked it forward. You'd take 67 minus the 64 divided by the standard deviation of 3. In part B, you'd be working that formula backwards. Solve it like a proportion. All right. Number 22, again, all about z-scores. They took away the picture. Jerks. So, but we already know the formula that we just talked about. It's the same formula. That's all we're going to run. So here it says an IQ of 76 is more unusual because its corresponding z-score, blank, is further from 0 than the corresponding z-score. Well, these are the multiple choice answers, so I got to go back. So I did use a little bit of calculator on this. So what we have to do is we got to figure out the z-scores for these two guys. I need the z-score for 76 and the z-score for 119, because we want to know which one is more unusual. Okay? So, z-score, 79. Excuse me, 76. So we're going to take 76 minus, well, what's the mean? 96. They tell us right up here. Here's your x bar. So we're going to take 76 minus 96. 96, yeah. And then we're going to divide that by, what's the standard deviation? 10. So divided by 10. So what is 76 minus 96? Negative 20. Divided by 10. So there's the z-score. So 76 is 2 standard deviations below. And this actually says round to the nearest hundredth, or it might say 2 decimal places. So this answer you'd tack on 0.00. Okay? So we need the z-score of 119, I believe. Yes. So we'll take 119 minus 96 divided by 10. What is 119 minus 96? How much? 20? No, it's not 20.
23.
Oh, 23. Okay. Yes, I'll go with that one. And then we're going to divide that by 10. What do we get? 2.3. And again, we'll just tack on the extra 0. Okay? So there are z-scores, because we need those because we got to fill in the blanks for whatever answer we chose. So who's more unusual? The 119. It has the higher standard deviation. So up here, we've got 3 choices. Which one is it? It's got to be B, because it says 119 is more unusual. Because what was its z-score again? 2.30. And what was the z-score of 76? Negative 2.00. Cool beans? So you'd choose the B. And you'd fill in their z-scores. All right. Everyone good on that? Okay. 23. Almost there. Assume that the women's heights have a mean of 65 inches and a standard deviation of 1.5. Again, on this one, I did use a calculator on this. Okay, I believe this is the last one I used a calculator on. Yep, there's your last calculator problem. So it says the women's height that corresponds with a z-score of 1.60. So we're working that z-score formula backwards. So we know the z-score is 1.60 equal to, do we know what the data element is? No, that's what we're looking for. Minus, what's the mean? 65. Divided by, what's the standard deviation? 1.5? Okay. So we need to solve this little equation. Again, how do we solve this? Yeah, because it's like a proportion. This guy's over 1, right? Do your cross multiplying. 1 times the x minus 65 is still x minus 65. And then like what you said, Jeff Lee, the 160 or 1.60 times 1.5 gives us what? Say it louder. 2.4. And now all you have to do is add the 65. And what do we get? That's how tall she was. Just solving your equation a little backwards. So 67.4. And again, we're going to do the same thing. So negative 1.50 equals, we don't know what the data is, but we're subtracting 65 and then dividing by 1.5. So we solve it the same way. What's negative 0.5 times 1.5? Negative 2.25 is equal to, go away, x minus 65. So what is x? 62 point what? 75. Yep. There you go. So you just come up to part B and you put in the 62.75. And the little directions down here say do not round, so keep it all. Any question on number 23? Number 24. All right. Again, another select all that apply. So that means there's more than one answer. So it says name 2 measures of the variation of a distribution and state the conditions under which each measure is preferred for measuring the variability of a single data set. So, the standard deviation is preferred when there are many data points. The z-score is preferred when there are many data points. The interquartile range is preferred when there are few data points. The standard deviation is preferred when the data is relatively symmetric. The interquartile range is preferred when the data is strongly skewed or has outliers. The median is preferred when the data is relatively symmetric. The mean is preferred when the data is relatively symmetric. The median is preferred when the data is strongly skewed or has outliers. Well, first off, let's answer this question. What measurements have we talked about that talk about the variability, the spread of your data? Standard deviation, and there's one other. Say it again. Nope. The mean is not about the spread. The mean is more about the center, not the z-score. Say it again. The IQR, your interquartile range. So that narrows things down. It's either A, C, D, E. So which one is it? It is D and E. Because this tells you when it is appropriate to use those. Remember, we only use standard deviation if we are symmetric. We only use interquartile range if we are skewed. The first two guys, A and C, that doesn't make any sense. Whether I have few data points or a lot of data points, that doesn't determine whether I use standard deviation or not. Whether I have a lot of data points. Just because I have a few data points doesn't mean I use interquartile range. Because remember, in order to do interquartile range, you at least got to have 5 different numbers to make that box and whisker plot. So that's why it has to be D and E. So just to kind of talk about these other ones. The z-score is not so much about the span, but z-scores are more about an individual data entry, telling you how far away. that doesn't tell you much about the variability. So that's why it can't be z-score. And again, like I said, median and mean, those are more about the center of your data, depending on if you were symmetric or skewed. So yeah, does that make sense? Okay, last question, then we're done. So in your own words, describe to someone who knows only a little statistics how to recognize when an observation is an outlier. What actions should be taken with an outlier? Okay. So there are two parts to this. So we're on part A right now, and then we'll talk about the part B. So part A, so we got a couple choices, and it says choose the best answer. So the outliers are minimum and maximum values observed in a data set. They should be treated as any other value, as the term outlier is just another name for the maximum and minimum. Outliers observe values far from the main group of data. In a histogram, they are separated by the others by space. Outliers must be looked at in close context in order to know how to treat them. If they are mistakes, they might be removed or corrected. If they are not mistakes, you might do the analysis twice, once with and once without. C, outliers are observations that are more than 1.5 interquartile ranges. 1.5 interquartile ranges from the median in a data set. They should be looked at in closer context to determine how to treat the values. Sometimes they may be included, but sometimes they are discarded. Outliers are observed values far from the main group of data. In a histogram, they are separated from others by space. Outliers should be ignored because they distort any calculations done and are not representative of typical values. The best answer. And remember, you are talking to someone who doesn't understand statistics. Who would you choose? Say it again. D? It is not D. Reason it's not D is because it says the outliers should be ignored. You shouldn't ignore outliers. Remember I said in class, they could be mistakes, but maybe it's something unusual in your data, something special about your data. So don't ignore outliers. That's not good practice. Say it again. You go with B. B is the real answer. Because again, we're talking about someone that doesn't know anything. So B says, right there, they're far from the main group. You'll see space. Maybe they know what a histogram is, but maybe they don't. But they'll understand that, oh, space. Okay? And then other things like if you look at it closer in context, right here, they could be mistakes. They may not be. You may run it twice with or without the outlier. Now, the other one that comes close is outliers are observations that are more than 1.5 interquartile ranges from the median. That's a lot of information for someone that does not know statistics to know. Okay? So, that's tough. Tough to swallow for someone that'll be like, what's an interquartile range? What do you mean by a median? And then obviously the first one, it's just silly nonsense. All right, last question. Part B. Which measure of the center, mean or median, is more resistant to outliers? And what does resistant to outliers mean? So, it says the mean is more resistant, which indicates that it's usually, well, actually, let's just answer this question. Who's more resistant, the mean or the median? The median. All right, so that narrows it down. It's either C or D. So let's read those. The median is more resistant, which indicates that it usually changes less than the mean when comparing data with and without outliers. The median is more resistant, which indicates that neither the number nor the magnitude of the outliers has any effect on the calculated value of the median. Which one is it? Now, I originally went with D, but D is actually not the right one. C is the better of the two answers. So, I know, right? Challenge flag thrown out on the field. Okay? Neither the number or the magnitude of the outliers is the key in that one. Okay? That's the key.
So it does change depending on how far out it goes?
Very little. The fact is, when I think about this, the number. If I have more outliers, that's going to affect your mean, or that's going to affect your median, because median is about counting in from those numbers. The more that you got out here, that changes your median around a little bit. Okay? So this says it has no effect. And because of that number right there, that's what, to me, throws this sentence off. And also that it says, does it say no effect or has neither the number has any effect. So this is basically saying it doesn't do anything to it. It does if there's a larger set of numbers. I mean, not like, and the magnitude is like the number size. Like if I have 76, 76 won't affect my median. But if I say I have two 76s, that's going to change my median a little bit. Just a little bit. Not much. Okay? So, yeah. C. Again, this is one of those questions. Just be careful on it. Read it carefully. Think about it for a second. Try to interpret those words. Okay? That's what it looks like. That's it. Yeah. Yeah.